All right, students, we are looking at growth and decay problems. We're going to look at, I think, about anywhere 5, 6, 7, maybe even 8 or 9 different problem types. All right, so let's get after it. So this first type of problem, it says if the inflation rate is 1.9% per year, the future price, P of t in dollars, of a certain item can be modeled by the following exponential function, where t is the number of years from today. Find the current price of the item and the price 10 years from today. Round your answer to the nearest dollar as necessary. Okay, they've given us a nice equation. We'll look up here and we've got a rate 1.9%. We'll turn that into a decimal, 0.019. The future price, P of t. Okay. And this is in terms of t, our independent variable up there. So looking at what they're asking for, the current price means, well, right now when t is equal to 0. So let's just plug in 0. That's going to give us 1500 times 1.019 to the 0. We know that anything raised to the 0 power is 1. So it's just going to be 1500. And when they want us to know 10 years from today, that means t is equal to 10. So we plug in 10 and let our calculator handle the bulk of that. So it's about 1811. They want us to round to the nearest dollar. All right. Not too bad, just plugging in some values and being able to interpret the equation. Let's go to the next problem. This is a half-life problem. We've got a radioactive substance, uranium-240, has a half-life of 14 hours. The amount A of t of a sample of uranium-240 remaining in grams after t hours is given by the following exponential function. And so we've got that function right there. Then they say find the initial amount in the sample and the amount remaining after 30 hours. Okay, well, once again, initial amount is going to be t equals 0, so after 0 hours, and the amount remaining after 30 hours is t is equal to 30, and we're going to plug those numbers into the equations. Pretty straightforward. 0 over 14 is 0, and anything to the 0 power is 1, so we're actually left with that coefficient right there. Might be a quick way of thinking about that. And then after 30 hours we plug in 30 to t, and we can just find that fraction and plug that into our calculator and get a nice solid answer. Okay, let's look at this one. We are not given an equation on this situation. This says suppose Miguel borrows $7,000 at an interest rate of 19% compounded each year. Wow, 19%, that's a whole lot of interest rate there. Assume no payments are made on the loan. Okay, so that means we're just going to use our good old formula here. Don't do any rounding. Find the amount owed after 1 year and the amount owed at the end of 2 years. Okay, so they don't give us a formula. We're going to have to pull that formula out. If you remember, that formula for something that compounded is A equals P times 1 plus R over N to the NT, where P is the principal, A is whatever that final amount is. So compounded each year or annually, that means that N is equal to 1. Turning that 19% into a decimal, we have R equals 0.19. 7,000 is our principal, that's P. So we could write this as A of t, the amount after a given time, is 7,000 times 1 plus 0.19 over 1 to the 1 times t. If we wanted to, we could just write this inner function, or inner expression as 1.19 and just write that as t. T equals 1 means plug in 1, so we have 1.19 to the 1. That's going to give us 8330. And then at the end of 2 years, that's just 2. So we plug in 2. So very similar to those previous problems. The only difference is here we have to create that formula, or sort of fill it in ourselves, and then plug in the 2 value. And you see we get 991270. Okay. This problem's very similar, just 1 or 2 items are different. It says suppose that $2,000 is invested at a rate of 4.1% compounded quarterly. Okay, so that's a little bit different. And assuming that no withdrawals, find the total amount after 8 years. Great. So 2,000, that's the initial amount, that's our principal. 4.1%, so we'll write that as a decimal, 0.041. Compounded quarterly means N equals 4. And they want to figure out after 8 years. First, I'll create that general formula. write it down here again, and then I'll start plugging in some values. So I put A equals blah blah blah, but really we'd say A of t. A is a function of t. So there's principal 1 plus 0.041 divided by 4 to the nt. So n is 4 and t is our time period. So this is our formula. We're going to plug in 8. So I'm just going to write 8 there and 8 there. Type that into the calculator and come up with a nice answer. Wow. After you notice he's investing, he's getting 4%. Miguel, I think, that one he was borrowing money at 19%. Kind of pays to be the bank in this situation. All right. So here's another kind of very real world situation. The car is purchased for a certain amount, and each year it loses 25% of its value. Okay. And this is a practical sort of question. It's not so much just plug in the numbers. This is after how many years will the car be worth $11,600 or less? Use a calculator, okay, and then write the smallest possible whole number answer. So like if it's going to hit that after like 2 years, then write 2 years. But if it's going to hit that, I mean, if it's $11,600 less in 2 years, then it would also be $11,600 or less after 3 years and 4 years and 5 years, because it's going to be decreasing every single one of those years. So they want to know, so to speak, the earliest time, the soonest time that it's going to be less than that amount, or exactly equal to. So sort of parsing this problem up here, each year it's losing, it's decaying in value, and they say that occurs once a year, on the year, so to speak. So that's an n equal to 1. It's not happening semi-annually or monthly or anything like that. This is what our final amount is, or less, I guess. So our principal there is the 37,000. Turning that 25% into a decimal 0.25, and then we know how many years. So that's the time value. If we write our formula down, that's going to be A of t is equal to the principal times 1 plus 0.25 over 1 times 1 times t. So yes, that's the value now. Thank you. Okay. Or at any given time. Okay, well, the value now. So 11,600 is greater than or equal to then whatever this, I guess this value, I should say, this arrow is indicating this whole thing here. And what I do wrong here? 1 minus, yeah, because it's decay. Thought I was going to mess that up. Okay, so 1 minus 0.25. So 1 minus 0.25 is 0.75, so 0.75 t. And we want to figure out that t value where this is going to be the case. So divided by both sides by 3,700. And it's going to get real kind of fuzzy here in a minute when we're going to, how we keep these greater than or equal to. So let's just say it's equal to. Let's figure out how long is it going to take to exactly equal $11,600. So let's just figure out exactly that value. All right. So you take both sides divided by 3,700, we get 0.3135 equals 0.75 t. And we say, how am I supposed to figure that out? And then we think, oh, wait a second, that's an exponential equation. I know how to deal with that. I can take the natural log of both sides and then utilize that property of logarithms where I can move that exponent out to a coefficient. So this is going to be natural log 3135 equals t times natural log of 0.75. Then divide both sides by natural log of 0.75. So t is equal to natural log 0.3135 divided by natural log of 0.75. Calculator magic gives me 4.03. So this tells me that in 4.03 years, it's going to equal $11,600. So if I say, what about after 4 years? Well, after 4 years, it's not going to quite hit that. It's not going to have decayed enough. But they want a whole number. So it's probably going to be 5 years if I'm kind of thinking this through. If you're not sure exactly, let's just plug in some values. Let's plug in 4 years and see what happens. So I'll plug 4 years into this formula right here. So, and I get $11,707. So it's close, but not quite, because we want to get $11,600 or less. I plug in 5 for 5 years to see how much it's going to depreciate to, and lo and behold, $8,780. So after 5 years, it will definitely be below that $11,600 value. So 5 is my answer. 5 years. It's going to take 5 years and it'll be below that. Okay. This next problem is kind of the same thing, but just from the opposite end. Instead of the money losing value, it's gaining value. So it says LaShonda deposited $6,000 into an account with 2.1% annual interest rate compounded semi-annually. Okay, so get that circled, n equals 2. Assuming no withdrawals. And you might say, well, what about if there are withdrawals? There's math and there's ways of dealing with that. Normally you take that in like an like an engineering economics class or something like that. Or some sort of, I guess, accounting, business, economics classes will also deal with that. How long will it take for the investment to grow to this amount? 7,500. Okay. So I'm just going to say, let's find out exactly how long it's going to take to reach that specific amount. Okay, they went to the nearest hundredth, so that's fine. So final amount equals the principal amount times 1 plus 0.021 divided by 2, all raised to the 2t power. So I'll divide both sides by 6,000 to be able to isolate some of these terms. That gives me 1.25 on the left-hand side. That parentheses term combined is 1.0105 to the 2t power. Same as last time, I'll take the natural log of both sides. And in doing so, I'll be able to bring that 2t exponent out here to the front. So I now have natural log 1.25 equals 2t times natural log 1.0105. Divide both sides by natural log 1.10105, and or whatever it is properly. I don't think I said it right there. Anyway, so and I should have a 2t on this side. Now, if I then divide both sides by 2, I'm going to try to get everything all in one shot here. So divide this side by 2, that side by 2. I would have t equals natural log 1.25 divided by 2 times natural log 1.0105, which gives me 10.68. That's exactly what they wanted. They wanted how long is it going to take, round to the nearest hundredth, and there we have it. Oh great, physics problem. So something kind of the same. They give us an equation that's a little bit different. So it says suppose the velocity v of t in meters per second of a skydiver falling near the Earth's surface is given by the following exponential function, where t is the time after diving measured in seconds. So this left-hand side is going to give us our velocity, and as a result of this formula over here. How many seconds after diving will the skydiver's velocity be? 67 meters per second. So we say he's going to hit, when is he going to hit 67 meters per second? And we have 89 minus 89 e to the negative 0.16 t. So a lot of similarities here, I guess, and once the problems start all looking the same, then we're in good condition. We're just going to subtract 89 from both sides. Then you can see divide both sides by negative 89. I forgot to put the e there, but now he's there. Left-hand side is going to be this decimal equals e to the negative 0.16. And we can convert this exponential equation into a logarithmic equation. We can say natural log of 0.24719 equals negative 0.16 t. Divide both sides by negative 0.16. And you end up with your t value. So just solve for t. Kind of interesting, you know, it's going to take 8.7 seconds here for him to reach that velocity. It's just the same type of problems we did in a previous video set, but now they have meaning. There's physical things that we've measured that are dealing with that. So speed and money and velocity, and I guess speed and velocity are the same thing. Suppose that $1,100 is borrowed for 6 years, interest rate of 5% compounded continuously. There, you were waiting for it. Now we've got it. So 5% is 0.05 continuously. That means we're going to use that A equals PE to the RT. All right, find the amount owed. So that, just going to plug it in. 1,100 e to the 0.05 for 6 years. And there it is, 1484.84. All right, these continuous compound problems are pretty nice. This is a very similar situation. This is Ali wants to buy a bond that will mature to this amount in 7 years. So this is what he wants it to mature to. How much should he pay for the bond now if it earns 4% per year compounding continuously? So he's asking, find the principal, find how much he's got to put in right now, which is a great question. Maybe he knows he's going to have to owe this much for, you know, some sort of, graduate work or whatever. He's just going to go study his master's, and he's going to need $5,500 in 7 years. So he's going to start saving now. How much does he need right now? So we've got the same formula, A equals PE to the RT. So final amount is 5,500. Initial amount we don't know is P. We know the R, 0.04. We know the time period is 7. So P is going to be that 5,500 divided by, so we can just divide both sides by that E to the 0.04 times 7. I can type all that in the calculator. No big deal. He's going to need $4,156.81 right now if he wants to have the 5,500. All right. This problem here is one of these exponential decay model problems. This is a biologist has a 391 gram sample of radioactive substance. Find the mass of the sample after 6 hours if it decreases according to this continuous exponential decay model at a rate of 4% per hour. Do not round in intermediate computations. Round your answer to the final nearest 10. Blah, blah, blah. Okay, 6 hours. Continuous exponential decay. 4% per hour. So that rate, like I said, it was that much per time period, and this is the number of time periods. It's 391 grams. That's the principle. So we have 391 grams, e to the negative 0.04 times 6. It's hidden right up there. 6. Calculator will take care of that. Getting close to being finished. This says suppose that the number of bacteria is growing according to the continuous exponential growth model. A sample of 2,300 bacteria selected from the population reaches a size of 2,984. So this is your starting amount, this is your ending amount in 6 hours. Find the hourly growth rate parameter. That's R. So kind of mess up there for a second. So yeah, 2,300 is the principal. This is the final amount. So we'll plug everything in and solve for R. So we've got left-hand side, right-hand side. We can divide both of those by 2,300. And I'm going to leave that as a fraction, equals e to the 6r. Once again, we can convert this exponential into logarithmic. Say natural log 2984 over 2,300. Then equals 6r. So that's turning this exponential into a logarithmic. Then obviously divide both sides by 6. Plug that into the calculator and you can get a great answer. All right. So look at this in reverse order. We talked about exponential growth, exponential decay, finding the time. We talked about semi-annual being compounded and using natural logs on both sides to solve for equations. Quarterly and creating that equation ourselves. And also having situations where the formula was already given to us. All right. I know this is a lot of work, but I know you're going to do great solving these problems on your own. Good luck.